morning children. Last class we completed exercise 4.4 till 9 sums. So today we are going to see remaining sums of the exercise 4.4. So 10 sum is a homework for you. We are going to solve today 11 sum. So what is the question given? Good morning children. Last class we completed exercise 4.4 till 9 sums. So today we are going to see remaining sums in the exercise 4.4. So 10 sum is a homework for you. We are going to solve today 11th sum. So what is the question given? By the principle of mathematical induction, prove that n greater than or equal to 1. N greater than or equal to 1. So 1 square plus, what is the question given here? 1 square plus 2 square plus 3 square up to n square. Listen, greater than n cube by 3. Listen here, greater than n cube by 3. Now we are going to prove the statement. Listen here. P of n be the statement. P of n be the statement. What is the next procedure we are going to apply? That is P of 1 is true. We are going to prove that is P of 1 is true here. So listen here, 1 square equal to 1 cube divided by 3, then 1 is equal to 1 by 3. They will be given means and this value will be greater than 1. This will be proved here because they are asking greater than n cube by 3 here. Here so 1 by 3 will be greater than 1. So 1 greater than 1 by 3 here. So here we are going to find that P of 1 is true. So here first condition will be, in previous sum we will proved there that will be 1 equal to 1. We are proving 1 equal to 1 here. But here, what is the question here? Greater than. So that's why we are using this P of 1 as true here. So now we are going to substitute K here. P of K is, now we are going to prove P of K is true. So listen here, 1 square plus 2 square plus 3 square up to K square greater than K cube divided by 3. K cube divided by 3 here. So then, what is the next step? What is the next procedure we are going to follow here? It will be K plus 1. P of K plus 1 is true. So we are going to prove P of K plus 1 is true here. That's 1 square plus 2 square plus 3 square up to K square. So here we are having, there will be K square plus K plus 1 the whole square. So here so we are already having plus K plus 1 in the whole square greater than K plus 1 cube divided by 3. So here itself in LHS side we will be having some values for this statement. So that will be K cube divided by 3 here. K cube divided by 3 plus K plus 1 the whole square greater than K plus 1 cube divided by 3. Now we are going to solve the LHS side. We will be going to prove the RHS here. So listen here. So what is the LHS value? So listen here. LHS, that is K cube divided by 3 plus, if you are going to abbreviate this one, A plus T the whole square format will be K square plus 1 plus 2K here. So now we are going to take the LCM. Now we are going to take the LCM because here we are going to put the greater sign, which we will be therefore going to find the greater one. So listen here, K cube plus will be multiplying this one 3K square plus 3 plus 6K divided by 3 here. So in this value it will be greater than this value because if you are going to abbreviate this one, K plus 1 the whole cube. A plus 1 the whole cube. It looks like A plus B the whole cube. A plus B whole cube, that will be A cube plus 3A square B, then plus 3 AB square plus B square. So now we are going to abbreviate this one. You will get the answer that will be K cube plus 3K square plus 3K plus 1 So this is here will be D cube. So this is the abbreviation of K plus 1 cube. So this value will be K cube 3K square 3K plus 6 here. So now comes into here. Here so we are taking this one. 1 by 3 will be taken common, means remain K cube plus 3K square plus 6k plus 3 here. 6k plus 3 here. Now listen here, this value k cube 3k square, it will be same here. So but here comes a 6k. Here we are having 6k, here will be 3k only. So here we are having 3, here we are having 1 here. So this value will be greater than that value. So this is a proof we are going to prove in here. That's why you are right like this. This value will be greater than a plus 1 the whole cube divided by 3 here. So this is the p of k plus 1 is. So the statement p of k plus 1 is true. So now we are going to write the condition here. That will be p of n is true for all the values. P of n is true for all the values of n here. Okay, understood children? So now move on to the 13th sum. So 12th one is a homework for you. We are going to move on to the 13th one. So what is the 13th question given here? That is, use induction to prove that 5 power of n plus 1 plus 4 into 6 power of n when divided by 20 leaves a remainder 9 for all natural numbers n. So listen here, what is the question given here? That is 5 p of n be the statement. What is the question given? That is 5 plus 5 power of n plus 1 plus 4 into 6 power of n plus 4 into 6 power of n when divided by 20 here. When divided by 20, then leaves a remainder. This 9 leaves a reminder, that will be 9 here. Now comes into same process we are going to follow here. So listen here, first we are going to apply p of 1 is 2. P of 1 is 2 here. First we are going to prove p of 1. Now we are going to apply here. So what is the value we are having here? That is 5 power of 1 plus 1 plus 4 into 6 power 1 here. So you will be get the answer, that will be 5 square plus 4 2s are 4 6 are 24 here. So 5 square 25 plus 24. What is the value getting? 25 plus 24, that will be 49 here. Here we are getting the value, that will be 49 here. So question will be given when divided by 20 leaves a remainder 9. So this value is not divisible by 20. So now comes into division process. So 49 is divided by 20 means is divided by 20. Will we get the answer? That will be 20 into 2, that will be 40. What is the remainder we will be getting? That will be 9 here. What is the remainder we are getting? 9 here. We will write it like this. In 49 we will be write like this. 2 into 20 plus 9. 2 into 20 plus 9. This value will be hence leaves a remainder 9 is divisible by 9. Divisible by 9. You will be write the condition here. What is the condition? Hence, now it will be divisible by 9. Hence leaves a remainder 9 when divisible by 9. When divisible by 9. So understood that? So it will be different one. So now next we are going to solve like the p of k plus 1. We are going to prove p of k plus 1. So come to the next step. So what is the question given? We will write like this. P of k plus 1 is 2. So now we are going to prove the p of k plus 1. What is the value we can give here? P of, what is the n value? That is k plus 2 because we will be having a plus 1 plus 1, then plus 4 into 6 power of a plus 1. 4 into 6 power of a plus 1. So here this will be same condition. When divided by 20 and leaves a remainder 9. And leaves a remainder 9 here. And leaves a remainder 9. So listen here. What is the values that we are having here? Now comes here 5 power of a plus 2, because 1 plus 1 will be 2. So plus 4 into 6 power of a plus 2. 6 power of a plus 2. You will be split up like this. 5 power, you will be split up this one. 5 power of a plus 1 into 5 power of, because this value will be remains same, means power will be added here. So comes here 4 into 3, here is only will be write like 6k power 6 power of 1. So 6k power 6 power of 1 here. So there will be write like this 5k plus 1. We are already find out the value for 5k plus 1. What is the value for 5k plus 1? That is, in this previous one, will we get the answer? What is the previous one? That is 5k plus 1 plus 4 into 6 power of k equal to 20m plus 9. 20m plus 9. M will be the sum scalar. M will be the scalar. M is a, listen here. M is a scalar. So even there we will be getting this one 5 power of k plus 1. In this plus value it will go so it will change into minus here. 20m plus 9 minus 4 into 6 power of k. Minus 4 into 6 power of k here. In this value we are going to substitute here. In this value we are going to substitute here. What is the 5 power of k plus 1? That will be 20m. M is a scalar. 20m plus 9 minus 4 into 6 power of k into 5 plus, here the 4 will be constant, 6 will be also constant. 6 into 4, that will be 24 6k. 24 6k. Will we get the value? That will be 24 6k. So here itself you will be multiplying this 5 into this term. You will be multiplying this 5 into this entire term. You will be 5 will be 100m plus 5 nines are 45 minus same concept only 5 fours are, that will be 20 5 fours are 20 into 6 power of k into 6 power of k plus 24 into 6 power of k. 24 into 6 power of k. So m is a scalar. This is this condition. If we apply this condition into here, so what is the remaining value we will be getting here? 100m plus 45 minus 20 into 6k plus 24 into 6k. This term will be looks like the same here, because 20 power of 20 into 6k, 24 into 6k. 24 minus 20, that will be, you will get the answer, that will be 4. So 100m plus 45 plus 4 into 6 power of k plus 4 into 6 power of k. You will be get the value 6 power of k. Now comes into right here, will be separate, split the 45 value. Split the 45. That will be 36 plus 9. So you will be split up the value 100m plus 36 plus 9 plus 4 into 6 power of k. 4 into 6 power of k here. Then here comes here, we will write like this 100m plus 9 plus 36 plus 4 into 6 power k. here itself we are taking common values. 100m plus 9, I will be taking 4 will be commonly taken from this two conditions. Will be taken commonly from this one is a 9 plus 6 power of k. Will be getting the value that is 9 plus 6 power of k here. 9 plus 6 power of k here. So now we are going to substitute k is equal to 1. So now we are going to substitute the value k is equal to 1 means we will be get the answer that will be 6. 1 means that will be 6, 9 plus 6, 15, 15 into 4 that will be 45. So the same value will be getting here. So 45 plus 9 will be get the answer. So listen here. Now we are going to take this term only we are going to take. So we are going to assumption the value. So listen here. Substitute the value like this, will be get the answer. So here substituting k is equal to 1. So if you are going to substitute k is equal to 1 means will be get the 9 power 6 power of 1 that will be 9 plus 6 will be get the answer 15. So now substitute k is equal to 2. Now substitute k is equal to 2 here. Will be get the answer that will be 9 plus 6 power of 2 is equal to 9 plus 36. This is also 45. Then now comes here. If you are going to substitute k is equal to 3 means 9 plus 6 power of cube, that is 6 6 are 36 into 6. 6 then 3 6 6 are 18, that will be 21. So 9 plus 216. That will be multiply this one 220. What is the value getting? 220. These three terms will be divided by 15. These 3 terms are divided by 15, a multiple of 15. So you will be writing here 6k plus 9 it will be divisible multiplied by 15 means you will be write the condition like this. Listen here. 100m plus 9 plus 4 into 15 is a constant for b is a constant because whatever value you are substituting for k you will get the answer 15b. So listen here itself we are substituting this one will be get the value that is 15 into 4 here. 15 into 4 100m plus 9 15 into 4 60b. What is the value you are getting here? That is 60d here. You will be write the condition like this 100m plus 60d plus 9 here. So here itself we are taking 20 from this here. We are taking so this term will be divisible by 9 means you will be taking 20 from commonly if we are taken from this term you will be getting will be 5m plus 3d 5m plus 3d 5m plus 3d here plus 9 here 520 will be taken commonly taken this one. This 9 term will be separated out. This 9 term will be separated from. You will be separating this one. So if you are taking 20 commonly from this term, 20 will be taken. 25 are 100 here. 25. Then 20 into 3 60 here. You are taking the 5m plus 3d. In this condition, will be this is divisible by 20 and remainder will be 9. Divisible by this term will be divisible by 20 and remember what's the remainder here? That will be 9 here. You will be write the condition right. Leaves a remainder 9 and divided by 20. So this is the condition for what is the final condition you are going to write like this. P of k plus 1 is true. P of n is true for all the values of n. Understood children? Okay, 14th one is a homework for you. 15th one neglect that one, neglect the 15th one. Okay. In today's class we completed 4th chapter. Next class we are going to start with the 6th chapter. Okay, thank you children.